Hello, hi, welcome to our physics class for today. Today we'll be looking at horizontal projection. Remember we started our classes on gravitational motion, so we are looking at horizontal projection, right? Under projectiles, we are looking at horizontal projection. So this is Noble My Science Tutors Online. You are welcome to our physics class. Please, if you have not subscribed to our channel, please click on the subscribe button and the notification button so that when we upload a new video, YouTube will notify you. Also, you can reach us through the WhatsApp number that's showing on your screen. Is that okay? So please get your writing materials ready and get settled so that we'll go to our class for today. I remain Otobo Michael. So welcome to our class on projectiles, and we're starting with horizontal projection. Horizontal projection. So what is a projectile? A projectile is an object that is launched into air and allowed to move freely under the force of gravity. So you can just begin to start to picture objects that can be launched freely into air and then they are allowed to move freely under the force of gravity. Like when you play football, right? Or you throw a javelin, or a bullet that is fired, a cricket ball, an arrow that is shot. All these are examples of objects that are projected upwards and then they are allowed to move freely under the force of gravity. Now, when you are standing at a height and you project an object horizontally, that is called horizontal projection. That's okay. So when an object is projected horizontally with a horizontal velocity u from height h, the object will describe what is called half a parabola. A parabolic curve is like half of a circle. You know what a circle is, so when you cut it into half, a curve that looks like that is called a parabolic curve. Now when an object is projected horizontally, it will describe a shape that will look like a quarter of a circle. So when you divide the shape of a circle into a quarter, the part that the object will describe, it will look like that. Okay, so this is what I'm talking about. It's like a quarter of a circle. So, and this shape is called half parabola. A parabolic curve is a complete half of a circle, but this one is half parabola. Okay, so that is one of the characteristics of a body that is projected horizontally with a velocity u from a height h. The object will move with a uniform velocity in the horizontal direction. So this velocity in the horizontal direction does not change. The only velocity that changes is the vertical component of this velocity of projection. It also has a uniform acceleration up and down. Okay, then the time it will take to reach this ground is the same time it will take to drop freely from here. And then the path that this object describe is called a trajectory. The path taken by projectile is called a trajectory. That is this part of this object that is falling, that is projected from this height. This part is called a trajectory. Okay, so this is introduction to horizontal projection. Alright, so now we'll go looking at the equations of horizontal projection. Equations of horizontal projection. We know that from our equations of motion, from the equation of motion, we know that the second equation of motion is when we discussed motion under gravity, we had that equation is equals to ut plus half gt squared, right? So for a body that is projected horizontally, the projection velocity is the horizontal velocity. This velocity does not change. The vertical velocity, the entire vertical velocity is equals to 0, so, and that is this one. So this velocity is equals to 0, so you have your h will be equals to 0 times t plus half gt squared. Okay, so your h now will be equals to half gt squared. So you can make your h. Okay, so this is your h, right? This is your h. H is the distance, is the height. So the equation for the height for an object that is projected horizontally is half gt squared, right? The time to reach the ground. From this equation, you can make your t the subject. If you make your t the subject, you have that 2h is equals to gt squared. Gt squared is g. Then your t will be equals to 2h over g. So by the time you square both sides, you have that t is equals to square root of that, square root 2h all over g. So you take note of this equation. So this is the equation for the time taken to attain to reach the maximum height. This is the equation for it, and that is what you have here as equation 2. This is the time to attain maximum height, or time to reach the ground. I mean to say, this is the time to reach the ground, right? Because you are projecting the body from a height, so this is the time for the object to reach the ground, not to attain maximum height. This is the time to reach the ground. Okay, so take note of that, time to reach the ground. Now, for you to find the range, which is the horizontal distance from the point of projection, the horizontal distance from the point of projection, or the distance covered in the horizontal direction, right? We know that in the horizontal direction, there's no force of gravity. Okay, so in the horizontal direction, g is equal to 0. Now, if g is equals to 0, it means that if we replace the h with a distance or range, if we replace it with the h with distance or range, then we'll have that ut plus half gt squared. Now, since g is equals to 0 in the horizontal direction, it means that this part of the equation will be equals to 0. So all this will be equals to 0. So if that is 0, we'll have that distance or range will be equals to u times t. Okay, so we know that from this first equation, from this second equation here, t is given to be this, so which means that u will be equal, substitute for t from this second equation to be u times square root of 2h all over g. So this will give you the range or the distance traveled by the object that is projected horizontally. This is the equation to find the distance or the range, and this is the third equation that is here, u times square root 2h all over g. So basically, these are the equations that applies for horizontal projection, right? So I want to see how we can apply these equations now to solve some problems. So this is a question that we need to look at, right? A tennis ball is projected horizontally from the top of a vertical cliff 50-meter high with a velocity of 10 meters per second. Find time taken to reach the ground, the vertical component of the velocity when the ball hits the ground, the distance from the foot of the cliff where the ball hits the ground. Okay, so you have been given that. If you wish, you can decide to draw the picture that is depicted there. The body is projected horizontally from a cliff, and the cliff is you can draw it. You can draw it yourself. This is the height, and it's given to you to be 50 meters. That is 50 meters. That was what is given. 50 meters. Then the velocity along the horizontal direction is given to you to be equals to 10 meters per second. It's given to you to be 10 meters. You know that G is equals to 10 meters per second squared. That one, you know that one. Cool. So if you know all this, you are looking for the first parameter I said you look for is time taken to reach the ground. That is time to move from here to here. And I said that the time to move from here to this point is same as time to move from there to here. The time to cover this seems as time to move from this to fall down directly. Okay, so from that equation of motion, from the equation we got, we had that time is equals to square root 2h all over g. That is the beauty of the equation. So try to remember them. So just substitute into this equation. You are giving h to be 50 meters. H is 50 meters. So substitute all this information into this equation. You have square root 2 times 50 all over 10. Right, so when you this 0 can cancel out, so you have square root of 10, and square root of 10 is equals to 3.16. So this gives you the time to reach the ground. Quite easy, right? So then the vertical component of the velocity when the ball hits the ground. When the ball hits the ground, we know that from this height, the initial velocity is equals to 0. So the vertical component of the velocity when it hits the ground from v is equals to u plus gt. This is equals to 0 initial velocity. So the vertical component of the velocity v is equals to 10 times time, which is 10 times 3.16. Okay, so that gives you 31.6 meters per second. Okay, so please take note of how the equations have been applied. Then the last part is that the number 3 says the distance from the foot of the cliff where the ball hits the ground. Okay, so this is the foot of the cliff, and this is where the ball hits the ground. Right, that's where the ball hits the ground. Okay. So the distance you are looking for is this. Yes, this is the distance that you are looking for. Alright, that's what you are looking for. And from our equation that we got, we saw that the range or the distance, we said that along the horizontal direction, g is equals to 0. Along the horizontal direction, right? Along the horizontal direction, g is equals to 0. And that was why we call that range or distance, or range is equals to ut. Now, That was what we got. Is equals to ut. So here, so the velocity along the horizontal axis is 10 meters per second. That is this 10 here, right? Then the time, we got it in time to be equals to 3.16. So just substitute to that formula, you have 10 times 3.16. So if you multiply that, you have 31.6 meters. So this gives you the distance from the foot of the cliff, or the range, the distance covered, or the range from the foot. So just see how the equations are applied, so that when you are solving your own, you find it easy also to solve your own problem, right? So we're going to your test page now. So these equations, they are for you to solve. Please solve them and post your answer on the WhatsApp number, right? Just paste them there. I will look at the questions and see the way you solve them. Then if there's any need for any correction, I will also make the corrections. An arrow is horizontally projected from the top of a tower with an initial velocity of 50 meters per second. If it reaches the ground 7 seconds later, calculate the height of the tower. Okay, so you already know the equation for finding the height. So use that equation. Don't forget that this velocity that you see here is the horizontal projection velocity, not the vertical velocity. Is that okay? So yes, this is the horizontal velocity of projection, not the vertical velocity. Okay. Then a bullet is fired horizontally with a velocity of this from the top of a building 15 meters high. How far from the foot of the building would the bullet be assumed to touch the ground? Okay, so here you are looking for the range. Okay, you are looking for the range, and we solve a problem that relates these two. So know the equation to use so that you have the right answer. Please solve them, snap it, put it on the WhatsApp number that is there. I will look at your method of solving, then I'll make my corrections if there's any need. Is that okay? So thank you so much. This way we are stopping our class for today. Please, if you have not subscribed to our channel, please subscribe to our channel. Click on the notification button, and so that when we upload a new video, YouTube will notify you. Right? This is Normal Science Tutors Online, and we are bringing physics directly to your doorstep. You can reach us through the WhatsApp number that is showing right on your screen. Right? So please solve all those problems. Check your textbooks too. You can solve other problems. Also invite your friends to come and enjoy what you are enjoying here in YouTube. So thank you so much. We'll see you in our next class.